Algebra is a different way of thinking in maths because instead of just using numbers, we're starting to use letters that can represent numbers. And these letters are called pronumerals. Pronumerals. So letters or symbols that represent numbers. And pronumerals can be just normal letters of the alphabet. Often X and Y are used, but they could be P, N, any letter at all, as well as other symbols like from the Greek alphabet. We have other symbols like pi, you might have seen. And alpha and beta. So all these different letters or symbols can represent a different number depending on the situation. And we can use them in expressions just like we do for normal numbers. So if we have x, we can have x plus 3. So whatever the value that x has, we're adding 3 to this. We can also have x plus 9, or we could have 10 take away x. So whatever value the pronumeral has, which is x here, we can put it into a number sentence or an expression, and we can figure out the answer if we know the value of x. But at the moment, the value is unknown. And that's one of the hardest things about algebra. If we don't know the value of the pronumeral, we just leave it as the letter on its own. One of the most important ways of using a pronumeral is when there's a number in front of it. So if we have 2a, this actually means 2 times a. So this is just a way that mathematicians have decided to save time. We don't write the multiply symbol, and we just write 2a. So if ever we see a number with a letter in front, or if we see a pronumeral with a number in front, it means multiply. So 4b is the same as 4 lots of b. b times 4. And the number in front of a pronumeral is called a coefficient. So there are quite a few new words to learn in algebra. Basically, it's like learning a new language. Once we've started making expressions with variables, we can just start describing them. So if we have x plus 3 here, this is the same as the sum of x and 3. Because sum always means adding or addition. If we have y take away 4 in this example, subtraction or take away, the proper name for that is difference. So that's the difference between y and 4. Because on a number line, we're thinking, how far is the distance between y and 4? What's that difference? Next, if we have a number multiplying by a pronumeral, like we saw before, multiply we call product. So this is the product of 2 and a. 2 is multiplying by a. The last one we can have is y divided by 5. And remember, divided by we can also write as a fraction. So these two are the same. And division, the proper name for that is the quotient. So this is the quotient of y and 5. In other words, y divided by 5. So we have the sum, the difference, the product, and the quotient. Now we'll start looking at a bit more detail about pronumerals, because there are actually two different types of pronumerals. And they're based on whether that number can change in real life or whether it stays the same, always. So pronumerals that can change are called variables. And a variable could be something like, we're counting the number of goals that you scored at soccer. So if G could equal the number of goals scored each week in your soccer team. So we're defining what the variable is, and we're saying it's the number of. Whenever we explain a pronumeral, it's always the number of whatever we're measuring. And the number of goals, you would probably score a different number of goals each week, and it's possible to change. So G is a variable here. So variables can change. But if a pronumeral can never change its value in real life, we call it a constant. So often constants are measurements of a distance. So one example would be d is the distance from Melbourne to Adelaide. So that distance will never change. It's always a certain number, and I think it's about 1,000 kilometers. Maybe a bit more. But a constant is always the same. The last thing we'll do now is look at how we can use pronumerals to build equations and expressions. So let's just go back to, what does expression actually mean? What's an expression in maths? An expression is basically just a number sentence. So we've been building expressions ever since we started learning maths. A really simple one is just 1 plus 1. Or 12 times 5 plus 17, take away 42. That's another expression. But now we're starting to make expressions that have pronumerals in them too. So something like 4a take away 8. That's an expression. Or b plus m plus 14. And expressions are a little bit different to equations, because an equation has an equal sign. So it's actually talking about two values that are the same as each other. So an equation is a number sentence with an equal sign in it. With an equals. So we've been using basic equations a lot too. 5 plus 3 equals 8. That's an equation. But now we can start using equations with variables and constants too. So 17 plus A equals B. And the final word to learn that's important for algebra is term. And it's not like a term at school. It doesn't mean time. It's a part of an expression or an equation. And it's separated by a plus or a minus. So let's look at an example of an expression. 5a take away 3b plus 17 times 45. So in this expression, we look for numbers and pronumerals that are together with a multiply or a divide symbol. And these groups of numbers are called a term. So in other words, we find the plus and the minus symbols, and they are the gaps between each term. So terms are separated by addition and subtraction. So looking at our equation up here, our expression, we have 5a, that's one term, because we have a number and a pronumeral, and there's a multiply in there too, even though we don't write it. But then we have a subtraction. So that means that's separating the next term along. And we always group the subtraction symbol with the next term. So the subtract 3b, that's all one term, because we have a number and a pronumeral again. Here we've got an addition symbol, so that's the gap between the next term. But if we have a multiply symbol, that means all of this is one term. Positive 17 times 45. So in this expression, we have three terms. Let's do one more example. So in this expression, we have 4a plus b take away 12c plus 5. So we're looking for the addition and the subtraction signs, and they are separating each of the terms. So we have 4a is a term, positive b is a term, negative 12 times c is a term, and positive 5. And positive 5 doesn't change, so it's a constant, remembering our language from before. So this expression has four terms in it.